one, we're going to find the radius of convergence of the power series, the sum from n equals 0 to infinity of x to the power of 2n plus 1 divided by n factorial. We're going to use the ratio test given here. I know you can't see it very well. All these photos I have on my videos are on my Facebook page if you ever want to save them. But let me write it out. You have the limit as n approaches infinity. We want the absolute value of a sub n plus 1 divided by a sub n. Now, filling everything out, this is going to equal the limit as n approaches infinity. And we only need to put the absolute value sign on the x. So we're going to put absolute value of x. And then when you add 1 to 2n plus 1, that's going to be 2n plus 3. Or you could have just add 2 to the 1, since that's like your slope. And the denominator is going to be n plus 1 factorial. And then we're going to divide by a sub n. This is your a sub n. That's the same as multiplying by the reciprocal. Absolute value of x. And then we have to the power of 2n plus 1. All right, now let's simplify all this. Let's do the x part first. So when you look at the x part, this is the absolute value of x to the power of 2n plus 1 minus, because this is in the denominator, 2n plus 1. So this is going to give you the absolute value of x squared. Put the square inside, and since it's squared, that's just going to be x squared. So let's pull that out. So we have x squared. Then let's write our limit as n approaches infinity, and we're left with this n factorial. Well, this is n factorial divided by, and expanding this is going to be n plus 1 times n factorial. So this cancels out. So this is just going to be 1 divided by n plus 1. Now what happens is as n gets larger and larger, our y value is going to go to 0. So what we have is x squared times 0, and that equals 0, which is less than 1, so it is convergent, but it means it converges for all values of x. Since it converges for all values of x, our radius of convergence is infinity. Thank you. Have a nice day. Bye-bye.